Make a difference on the detector and the LED, or do you use? You could theoretically you could use the LED for both being in the detector and the LED.
Well, they are not so
right?
sensitive.
Yes, yeah,
most of them.
you can theoretically, and we
But there
I've
are
experimented.
two different components.
Yes, this is a. Yeah, it's first a different type of light because it's infrared light, but it's the other one. It's an actual different component that is much more sensitive.
Yeah, it's
if you want to use
optimized
the
for
LED as a sensor, is a little bit of a hack the way you do it. It's not that it's something like you need to charge the LED up, so you put electricity inverted on it, and then you calculate how much time it takes for it to lose. It's like
I was only asking because I was thinking the way you put the backpack on, then you could use them both as light emitting or light sensor, so that you would, like you were trying to combine all these components into one big thing. So if this component was both a light emitter and a light sensor, then you would only need this, and then you could have both functionality.
Yeah, you can have them like ice or something.
Exactly.
Yeah.
So then you can have it like ice, but then you could
Light up.
also have them emit light.
You could have them white LED, because you don't have white right now. It's only
it's just
blue.
colorful.
It was just a suggestion for future improvements.
Yeah, that's a good idea. Because then you can have it like a flashlight. And
I mean, we are also hoping with we have this like the way we did this right now is that you've seen the prototyping backpack. I think it's the one that we even made the earring for. It was this backpack that was like full of holes that you could solder all the way. This one, it's kind of a evolution of that because it still has quite a few connections into it. And you have like some jumpers that if you just like put a little bit of solder, you can different the routing. But that one, you still have a lot of flexibility to solder your own components. And this one with the LEDs, it's actually a very simple exercise to just solder the two LEDs on the top. So I mean, with that one, then we could just get LEDs off the shelf and create your own. So we could make two in different colors. I should make a David Bowie one.
And you could, if you have white and you have a color sensor, then you could, like the Osobot, the small robot that line follower, and it checks the color of the line under it, and it brights up with the same color. Then you get a sense that you can, because that's how a camera works. It's a light sensor that with a lot of small pixels that senses the color.
I think this idea of having stuff going through the eyes can be developed a lot. It's a very interesting approach. Okay, I'll go back to this.
Sorry, but we have about 25 minutes.
Okay, I'm gonna speed it up. But okay, so the infrared light, now I have it directly into a LED, and well, see if you can get that in the camera. But it can detect when something goes in front of it. And what it becomes really nice if you use it to change the color of the light. So I'm just going to go back to my previous example. Put a bunch of LEDs. So now I can use it to modulate the color as well. And, this can be something to detect. It can be like a little creature that if you flip it upside down, it gets desperate and move in a different way. So yeah, I think we can use the light sensor with a lot of the infrared light sensor with a lot of different interesting things. Okay, so that's it for these 2 new backpacks. So we're hoping that you guys can experiment different
And
activities
you
with
don't
it.
have them in this box right now, or?
No, but we will send them to you. I mean,
No,
because
the backpacks, are they, do you sell them already in this
what
package?
we did
or?
with the Kickstarter backers
Yeah.
is that for those who got that package, the developer kit, they came as soldering kits.
Okay.
So you could solder the eyes.
Yeah.
But we are going to have them pre-soldered and have that as a product too. So the ones we're going to send to you are already pre-soldered.
And then that's going to be another kit for the backpacks, or is this one going to have a backpack?
Well, this one, the robotic creatures won't come with this backpack, just come with the motor one.
Yeah.
I mean, that's also now in the pipeline. We have a bunch of backpacks ideas, and it might be that we make a kit that comes with more, but it might be that we're gonna sell them separately.
Yeah.
Yes.
But is the goal to integrate all backpacks into one? Or
Absolutely not.
Okay.
Absolutely not.
So when you were saying you were going to combine these, you were thinking.
I mean, this is
few
just
functions.
because these are 2 prototypes. So I mean, and because the functionality can be separated very easily. But we see this more powerful coming with the 2.
Yeah,
At
and
the
then
same
you will
time.
make another backpack that has 2 other combinations. Or
Yeah,
something.
exactly. We can tap into like a very large library of different sensors and different things that don't require the same amount of hardware development. It's pretty much just wire them up. So I mean, we have prototypes for like a sonar distance sensor that can measure.
Do you have a NeoPixel?
Yes, the
backpack?
NeoPixel.
Because I made one on my own, but they have
It's
they
5
have
volts.
that's the biggest part. But they have their own timing sequence to
you need
program.
to have a library to
Yeah.
handle them, but that's not a problem. The biggest problem is that they operate at 5 volts.
Yeah.
So the way we're thinking about it is a NeoPixel would need to have its own power, and
Yeah.
it can power the Quirkbot instead. Because the Quirkbot works at
Yeah.
5 volts.
Yeah.
It's just the battery that can't deliver it.
Yeah, and you can put it inside in the middle if you take the ring NeoPixel one.
Yes, yeah,
Because it's
with
it's
the
a
perfect
nice
shape for
yeah.
it. Okay, so all that said, we've been concerned a lot after we talked a few months ago with like this regards of this approach to programming versus the text approach that we have a lot of
or the
knowledge
just the
and
sequence
the
approach,
sequence.
because the microcontrollers are sequence based.
yeah
So
and like the possibility of just tapping into that existing knowledge base and we gladly came up with a restructure in the way the library is done that will allow that in a better way. So I'll just give a quick example. In terms of, you still cannot write text in the interface.
No.
So that's definitely high up in the priority lists that you can just come here and edit it. And we've been actually a bit in a dilemma between fully committing to CodeBender and staying Arduino because Arduino is about to release their own web programming platform. I mean, they promised that last summer, and it's been delayed, but now you can feel, and we really feel that's gonna have a huge impact in CodeBender. I mean, I'm not sure they will be able to keep up with the. So it's a little bit like we're waiting a bit because that might change the direction we take.
Have you seen RD blocks?
The Blockly. Yeah, and that's another thing that because of this new approach, we can also go into the block programming. That wouldn't be a huge step from that. Because
basically that's what we had a workshop for the national IT strategy and how we should integrate programming into the schools yesterday, and it will most certainly be like block programming on all levels. So it should be nice to have that possibility.
And I don't think it's really far from that. But okay, so for now I'm gonna program them in Arduino. Because because of this thing.
And you support that, and you will support that approach as well, from the Arduino IDE.
I mean,
because then you can have RD blocks. You just it's a plugin for Arduino. You just block program and it on the background.
The thing with that is that I'm not sure how much flexibility they have with the.
It's your your function. They are not.
We would need to write our own interpreter.
I understand.
But that's not a huge work. But okay, so let's say an example where we would want to. Let's see. We have if we want to have a sensor like a circuit touch, the old Make It Touch that we changed the name. And I want to get that to blink a LED. Okay, so the very simple one. If you would do that visually, in here you would create the circuit touch, and you would see LED. And you say, okay, I want the circuit touch on the horn, and I want the LED on the left eye, and I would just connect it here, right? But if we want to let's actually think in steps and instructions. The idea is that we could do this higher level thing of, okay, we're going to have a sensor, right? So let's put the sensor here. Let's give it a name. This sensor is going to be the trigger. And we're going to have a light, so let's call that the eye. And now let's program it so it blinks when the sensor detects. In that, we could just switch to text. And now I'm going to copy and paste in Arduino, but imagine that this is happening in here. And I'm just going to close this so it doesn't interfere with Arduino. That's a good thing to know. For now, you need to
on the USB.
You just need to make sure to close the browser because otherwise they will conflict. And let's go into this text. Okay, so I have the trigger, I have the eye, I configure the trigger, I configure the eye. And now I could write code that is very usual. So I could just write if, and then I have trigger dot out get. So I get the value of the trigger. And if that value is higher than 0.5, I can get the I light and set it to 1. If the value is larger or smaller than 5, then I set the I light to 0. And let's upload this one.
You can upload it straight from the Arduino interface.
Yes.
Yeah,
I mean,
if you close the browser.
Yeah, but what kind of Arduino is the Quirkbot
a
detected
Quirkbot.
as? Oh, there is.
Okay,
So, I mean,
so
that's
you
the
still
thing.
have the Quirkbot firmware in it, so you don't have to reset
it is
it. And
the same
yeah.
code.
Yeah, but it's when you upload it, you upload
It's not
it.
a Lillipad.
You have your own.
Yes. So
okay.
the both
Yeah,
things
yeah,
that you have two things you
So
need to
I couldn't
do.
do it on my computer if I only
Yes,
had the
you
Arduino.
can. Because
I
you
need
can
to-
You
install
have to
that.
install
Yeah, but
the
I need
drivers.
I'm trying to say I need to install.
Yeah, and that's a problem in the schools.
Yeah.
Yeah.
But is it with boards too? I mean,
But, sorry.
drivers apart.
Yeah.
Like, but just to get the Quirkbot in here, it's like installing a library in
Yeah.
Arduino. It's downloading a file. So I don't think that is a problem.
No, I just wanted to know if you needed to do that, or if it was in the standard Arduino
Library kit. Yeah.
Yeah.
But I understand.
No,
this.
yeah. But I mean, it's as simple as going to library,
Yeah,
searching, install. Actually, Arduino is doing that approach for themselves too. Like they're gonna have all their components just downloadable. Okay, but then now we have this linking.
Yep.
So the advantages of this is that it gives you the whole, easy to grasp, object-oriented
Yeah.
approach.
Yeah.
And you still can do
Yeah.
the ordinary programming. And there are situations, I mean, this is a very simple example, but there is other ones that it actually becomes much more powerful than the visual interface, which is, for example, here, it's a little robot that it gets scared if you're not holding its hand, okay? And if you're not holding its hand, it's blinking its eye really fast. And the moment you hold the hand, it calms down. So, I mean, the approach for that is that, okay, let's have a trigger, and let's have two waves that represent two behaviors. We have a wave that is a calm wave, and we have a wave that is a stressed wave.
Yep.
And we have the eye. So we set up the trigger. Okay, so the trigger is going to be the right arm. And we set up the calm wave the calm wave is a long wave, 5 seconds, so it's smoothly transitioning. And the stressed wave is just 0.18 seconds, and it's a square wave, so it blinks fast. And then we have the LED in the left eye. Then what we could write in the code is something like this. If the trigger is higher than 0.5, connect the light to the calm output.
Okay.
If the trigger is smaller than that, then connect it to the stressed output. And this is something you cannot do on the visual programming if you don't have like a list or something like that.
This is really interesting because if you read this and understand this, then you understand how the things work. You don't have to remember all the syntax and write it, but you have to be able to read the code and understand and see what it actually does.
So I think this is going to be super powerful.
This is a level of...
So you could, for example, create on the visual two, complex blinking behaviors. Yeah. But you don't have the intelligence there to okay, but I only want this behavior if it's looking there, and I want that behavior. Yeah. So you could, jump in here and write just a little bit of code that actually does that.
Yeah. Or just change
logic.
something or change the parameters if you want. So.
Yeah. So, this was a total breakthrough because it looks, just normal Arduino, but it was a lot of magic to make it work this way. But I was like, wow, this can be really, really powerful because now we're not competing anymore between two. We're like...
You can combine it. You can have different approach depending on what you want.
And, the idea of having... let me program this one so we can see it. Okay, so it's stressed, but then if I come and hold the hand, then it comes down. So this, for example, would be how you could start the programming. Okay, we're going to have a trigger. We're going to have two waves with two different represented two behaviors. And we're going to have that. And the way we're thinking this is going to work is that it's not that you're going to have the whole area to just edit, because that brings a lot of complexity in terms of like, we don't know then what we can translate to text or not. But the way we're going to do is that we're going to have an area here, so you can write some initialization code. You have an area in the setup.
And you still have your own codes for initial. It's just,
exactly. So like this block won't change. You can't edit this.
No, it's locked.
Yeah, exactly. Yeah. But then, and I mean, we even...
So you can't destroy the code that is necessary. Okay, but you can add something.
And then you can... Or, I mean, if you start with a completely empty canvas on the other side, then obviously you could just write code.
Yeah.
But the idea here is that, then we can just visually show that with like a little symbol here, like this program also has custom text.
Yeah. Okay.
They won't conflict with each other. So, I think that's our take on how we're going to take the
I think that's
combining.
Good idea.
And then what I've been looking at with Lockly, because I've been looking into the implementation. I mean, creating blocks that would do this thing, it's not a super hard task. It's basically writing this interpreter. Yeah. And I mean, we still believe a lot in this because this is, it's what set us apart as well with like this.
Yeah, but it's not really computational thinking. It's not that structured and sequenced. So
it's another way to think computation as well. It's I think it's important to always keep the possibilities open. And this is very easy to jump in and start doing it and kind of get mesmerized and jump into this. But for the Blockly, one approach for that is we could have like a branched project that is like it could be another address that you just have the Blockly interface and you can drag that around and you can upload.
You don't have to integrate it with your system.
You don't need to integrate like you save the blocks and everything. It can just be a standalone project, and probably that's how we're going to test that.
Yeah, I think that's a good
because it's faster to just do something that it just still talks to the compilation server and everything. And test it around. I guess I talked what I wanted to talk. And
you still got 7 seconds.
Okay.
Then it's 25 minutes.
Okay.
Okay.